I've written a Windows desktop app to help me learn about 2D perspective transforms. I wanted to learn how to remove perspective from an image, but also add perspective into an image. If we have a look and load something like that, we can see that there is a lot of perspective in that image. Left pane is from, the right pane is to, and we've got a splitter window that allows us to alter these two panes, the size of them. So the goal is to remove the perspective and make the right look as if we're standing in front of one side of the building. So let's choose the right hand side of this building. So we need to set up the quad that we want to remove the perspective from, which is something like that. Something like that, I suppose. So now you can see it looks like we're standing in front of the right hand side of that building, as opposed to looking down the street onto the right hand side and the left hand side of the building, and obviously seeing that foreshortening and perspective. So that's removing perspective from an image, which is all basically down to mapping one quad on the left onto another quad on the right. This method on the right hand side, we can make that a bit narrower. So on the right hand side is the result of mapping the quad on the left onto the quad on the right. So if we wanted to add perspective, we could have a look at an image that hasn't got any. And again, we're mapping quads on the left to quads on the right. So we want to add perspective to everything on the left. So let's change the quads on the right, something like that maybe. So now we can see it gives us the effect that let's make that a little bit bigger. We're standing in the middle of the road, and the buildings now are on our right hand side. Again, same method, mapping one quad on the left onto another quad on the right to give us this effect that we're after, and we can change it in any way we want to. Get all strange perspective effects. If any of the quads on the left or the right no longer are convex, then I don't bother trying to render that. But as you can see, they're both convex now, so we have that result. So how did I do this? I read on the internet about homography, and I saw a website called math.stackexchange.com that had a good description on how to do this, how to map one quad onto another. And it involves basically taking a point, for instance, the top left here and the top left there from the left and the right panes, and building up a 9 by 9 column by 2 row matrix. And obviously you've got 4 points, so you end up building a 9 column 8 row matrix. You can then call that, say, P, and then you can say pH equals 0, and then you can use this decomposition called singular value decomposition. I think it's called singular value decomposition, maybe singular vector decomposition. I'm not sure, I'd have to look again. But anyway, we can use that to decompose P, and then use the singular vector V in that decomposition, and that is our solution to H when we say pH equals 0. And then you can use that to build up a transform, and that transform will then have the perspective in it that you've created by mapping the points of quads. So I can put a link to the math.stackexchange.com question and answer that helped me. I can put a link to my GitHub that's got this project freely available for people to use, to download. One other thing as well is I did not know how to do SVD, the decomposition. I didn't want to reinvent the wheel, so I thought I would learn about eigenlib. So I used eigenlib to do the heavy lifting with the SVD to extract that singular vector v component. So if you want to learn a little bit about 2D perspective transforms, how to introduce perspective and remove perspective, and also you're interested in learning how to use eigenlib a little bit, introduce yourself to that, you could have a look at the GitHub page and that will have everything that you need. Okay.